I'm Yuki, and he is Peria. We are in binding subteam in platform architecture team. Today, we'd like to introduce two our projects. The first part is Interop on CrossOrigin Properties. We are now trying to implement CrossOrigin Properties conforming to the web spec. And CrossOrigin Properties are properties that you can access across origin, such as window.post message and location.href. Today's Blink implementation has two problems on cross-origin properties. The one thing is that web ideal spec says ideal attributes must be implemented as ECMAScript accessor properties. However, Blink's implementation is implementing it as date properties. That is different. So we need to fix this point. And the second point is cross-origin GetOwnProperty helper. See this example. Suppose you are in window A, and you are now accessing window B's post message. And if window B is the cross-origin, then the spec says, in order to prevent cross-origin access, or how can I say, in order to prevent leaks between origins, magic works here, and you are accessing window B dot post message. However, you get a function created in realm A. You are accessing realm. So this is a magic called cross-origin GetOwnProperty helper. And HTML says this magic only works if it's this cross-origin. If it's the same origin domain, this magic shouldn't work at all. However, Blink is currently applying this magic always, regardless of whether it's same origin or cross-origin. This is the second point we need to fix. So the story should be simple. We need to fix 2 points in cross-origin properties. However, there is another problem. Blink does not support incumbent realm for now. So if we simply fix the cross-origin properties on these 2 points, then our navigation breaks. That is the problem. So let's see what is the incumbent realm. The incumbent realm is the realm of the most recently entered author function. Let's look at this example. Suppose we have window A and function A, and it calls window B's function B. And function B is like this. Yeah, inside it, we are trying to navigate window C to another URL. So in this case, the navigation window C.location.href setter function is sorry. Yeah. Looking at that navigation time, at that moment, the most recently entered author function is function B. It's not A nor C. So the incumbent realm is, in this case, is B. So yeah, please note that the incumbent realm is not A nor C. It's B. Yeah, this is very important point. And spec says navigation must be resolved relative to the incumbent realm. So in this case, window B's URL should be used to interpret that URL string. And in the same example, when we are running href the setter function, the currently running function is the href the setter function. So its realm is the current realm. So in that moment, the current realm is realm C because we are running Windows C's function. And the incumbent realm is realm B. So in general, incumbent realm and current realm are different things. So let's look at Blink's implementation. As Blink does not support incumbent realm so far, so we are doing a little bit different things. First, href is implemented as a data property. So there is no ECMAScript function when we are operating actual assignment operation of href. So the current realm doesn't change. So when we are running C++ callback function for href, the current realm is realm B because we are inside function B. And realm B that matches the incumbent realm that by HTML spec. So Blink is currently using current realm when navigating instead of incumbent realm. And let's see another example. Let's consider about a replace operation. Replace is an ECMAScript function created in this case realm B because Blink always, even if it's the same origin domain, we are performing cross-origin property cross-origin GetOwnProperty helper. That magic I said I introduced. So replace ECMAScript function itself is created in realm B in this case. So and that realm B matches the incumbent realm specified by HTML. So again, Blink is using the current realm instead of incumbent realm for navigation. Yeah, this is the current situation we are in. So we'd like to fix these things first. So yeah, we need to fix, we need to support the incumbent realm before we fix cross-origin properties. So we'd like to implement the correct incumbent realm as spec. And let's see the exact definition of the incumbent realm. I already introduced the first definition, the most recently entered author function. However, the spec has the second definition too. The second definition is the author function that originally scheduled a callback. This second definition is necessary because sometimes we don't have any author function on the call stack. Let's see the example. Let's see our example. Yeah. In this case, function C is scheduling a callback function. Callback. So we are using window.setTimeout API to schedule callback. The scheduled callback is location.replace.bind. The result of it. Yeah. And unfortunately, this bind does not create a new function. So location.replace is a web API. It's not an author function. And bind does not create an author function. So overall, this result is not an author function. So there is no author function at all on the call stack. So in this case, we need the second definition. So in order to to determine the incumbent realm, we need to look at which function schedule this callback. And function C is now scheduling this callback. So function C's realm is the incumbent realm for this callback. And this is pretty important and interesting point. You cannot tell the incumbent realm from this line itself, set timeout lines itself, because we need to know who scheduled this function, this callback. So we need another information. So this is a pretty important point. ECMAScript function itself is not a callback in terms of IDL, web IDL. In web IDL, callback function is ECMAScript function, scheduled function, plus the incumbent realm at the time of scheduling. We need one more information to build up the ideal callback. This is pretty important, and many people are confused that callback function is just a ECMAScript function. It's not correct. Yeah, please remember this point. And now mission is updated. We'd like to support cross-origin properties, but we need to first support incumbent realm. However, in order to support the incumbent realm, we have to support all the callback correctly with the incumbent realm recorded. So this is our new mission. So we need to support all the callback and its use cases correctly. And the current status is binding team already re-implemented all the ideal callback function and callback interfaces. And for use cases, we already fixed 20 use cases of callback functions and 12 use cases of callback interfaces. So we are hopefully close to the end. Yeah, but still some remaining we have. Yeah, node filter, event listener, and some unique use cases of CSS painting API and custom elements and so on. Yeah, yeah. But we will fix everything about callbacks and yeah. And summary of my part is yeah, that's almost all. Yeah, we'd like to support cross-origin properties, and in order to do that, we have to support incumbent realm, and in order to do that, we have to fix all callbacks. Yeah, that's all of my part. Yeah, the next part is yeah by Perez.
Could you keep your question by the end of my
Okay. Yeah. I'll answer question after Perez-san's talk. Yeah.
So continue about the re-architecture of ideal compiler. Well, first, let me introduce the ideal compiler. What it does. The ideal compiler converts the web APIs defined in written in ideal into a C++ binding code, as you see in the slide. And let's see how the current ideal compiler works. Simply a design, can I say, if you have a one interface defined in ideal, then you can the ideal compiler output binding C++ code. And you may have another file that defines the partial interface. Then the partial interface is merged into the same class, and the output file is also one. Then you can also have the interface mixing. It is also defined in the same output file. Next, you can have the inheritance of the different interface. Then you can find the IO compiler output another set of C++ code, but it needs some information about the original based class foo. So it also needs an idea about all IDL files of foo. And don't forget about the componentization. Then we can define another one more set of binding files defining another component in main modules. This is very complicated design. So why it became so complex? because the current ideal compiler was designed and implemented in 2014, and after that we introduced. After that, the many web ideal specs and many web specs are updated, and many syntax are introduced, and we in Blink introduced a componentization. It split some bindings code into some different files. So these changes introduced many issues around our ideal compilers. Here see some issues, but I don't explain about all the issues. Some are about unexpected behaviors, some are about implementation limit, and we need to support some new features about web ideals. The next question is why? Why we keep these issues still left? The root point is we have two root points. One is a type references are not handled well. Another one is a componentization, as I said. So to resolve these issues well, we are planning to remake the ideal compiler from the scratch. In current ideal compiler works like this workflow. The blue arrows showed a task in the GN. And you can see you have 1, 3, or 5 tasks to generate a code. And it's too much to generate a to convert a files. So we want to remake the flow as you see in the slide. First, we load all the IO files in the component and the output database. Then we merge all databases per component into one global unique database. Then we can generate all ideal binding code, C++ code from the unique global database. The key point of the new workflow is one is to have a unique global repository database. So it contains all information in ideal file that is written in ideal files. So the type of references should be resolved well. And all structured objects are linked directly, so you can refer other types without looking into some ideal files independently. So, and another key point is to change the C++ code. In this context, I don't mean that to apply this Chromium coding style, but how we make the V8 objects, mean wrapper object of Blink object. Now we can generate a wrapper object for two classes, base interface class and a parser interface. But we have to handle some other interface class if we have some components or other than modules. core. Currently, we have core and modules, but we may have more components. Then we have to work for the other additional components. So the ideal compiler also works for it. Another one is a use another template library. Template library Ninja is somehow difficult to apply the conversion, and a candidate template library Mako is good to work with a Python style code in the template files. So this is our plan to make the new ideal compiler. That's all for my part. Yes, that's all. Thank you. Any questions for Yuki's father? It's a part, is okay? Yeah.
Will this implement the latest web IDL?
Could you just, okay.
Will the new web IDL compiler implement the latest version of the web IDL specification?
Read this question?
Yeah, I think so. Yeah. So I know that in a spec that I worked on, it doesn't conform to web IDL. Yeah. There's changes in the spec. And there's no validating web IDL compiler out there. So what do we do as call our web IDL compiler and then find the current IDL file bugs?
So please find about need to address any issues case by case.
Yeah. The thing is that the new compiler that's strict web IDL, existing IDL files don't validate anymore.
I don't think it will happen. Basically, we will keep the backward compatibility as much as possible. And it's not reasonable, then we will prepare something substitute way. We will continue to support some kind of Blink specific ideal extension, such as extended application.
Understood that there are things about overload and location of overloads in different IDL files that are now no longer valid. Things with IDL spec. So I wonder if the strict mode of this new compiler to tell us this is invalid. I'm going to generate your code for you, but you got to fix it. So,
that's an interesting case.
Yeah.
We could show a warning, not error, or like use it. We could have two modes.
I'll fix the IDL.
Basically, so our main goal is to make a Blink IDL file as spec conformant as possible. So we find new issues, so one by one, but not perfect. But that's our main goal. So make it a spec conformant. Question, right?
I'm not sure I remember the question. So the original issues is one is the location, which is not the artifact. Yeah, but the another is you are using CrossOrigin line. Yeah, that's true. In the I can you go back to the slides
Yeah, that's right. If you fix the first problem, I thought you will go into this pattern in the nothing place.
You are pretty smart. That's true. You are.
So you can fix the first problem.
Like, this is the thing where you return the same origin function instead of the CrossOrigin wrapper thing. I think I tried that a long time ago. Like the current realm doesn't set correctly. The current realm, like we're using the current realm for the URL. That was like concept. It's not the right realm.
We are introducing the incumbent there. So we
Yeah.
can't make that change.
I think when Daniel tried that thing, our current context handling was broken for lazy access affair.
Even more broken.
Yeah, yeah.
Yeah.
Now the situation is a little better. So yeah, I think
I see.
Hirano-san is right. But however, we have another issue. Because in your idea, we need always create accessor function when it's used. However, it's very costly. Performance regression. Yeah. For most cases, we are bypassing creating actual ECMAScript function object, meaning lazy access affair optimization technique. In your idea, we cannot apply lazy access affair optimization. So that's not. Any other question? Otherwise, that's the end of our session.